Every year, millions of cars reach the end of their journey. But the end doesn't mean destruction, it means rebirth. These vehicles don't simply disappear. They become the source of new life for steel, aluminum, and the technologies of the future. Across the world, over 40 million tons of metal from old cars are recycled each year. Reborn as the foundations of bridges, skyscrapers, and new automobiles. An old car isn't waste, it's artificial ore, a valuable resource that can be reused again and again without losing quality. Today, we'll uncover, step by step, how a rusted car body transforms into shining new steel, and how that steel becomes the backbone of a new industrial era. When a vehicle is officially retired, its journey doesn't end in a junkyard. It begins at a recycling facility. Here, everything starts with precision. Each car is photographed, assigned a unique identification code, and logged into a digital system that records every detail, from the model and year to mileage and engine condition. This data helps determine which parts can be salvaged and which will go into the melting furnaces. Modern vehicle recycling centers are not chaotic scrapyards. They are highly organized industrial hubs with streamlined workflows and strict quality control. Before dismantling begins, engineers remove everything that could pose a risk: fuel, motor oil, brake fluid, coolants, and batteries. Traditional lead-acid batteries are recycled almost 100%. The lead and plastic are reused, and the acid is neutralized. Electric vehicles require a special process. Lithium-ion batteries are sealed and sent to specialized facilities for safe recycling. Everything that could ignite or pollute the environment is removed first. Even drained fuel is reused, often to power generators and machinery within the plant. Here, the guiding principle of industrial recycling is clear. Nothing leaves the line without purpose. The next stage is dismantling. The car is lifted onto a platform, and specialists begin with the outer components: doors, hoods, wheels, glass, and seats. Wheels and tires come off first. Steel or aluminum rims go for remelting, while old tires are shredded into rubber granules used for road surfaces and sports fields. Glass is cut with precision machines. It's made of multiple layers, and even the PVB polymer that holds the layers together is recycled for sound insulation. Next come the plastic panels and wiring. Copper wiring harnesses are carefully removed. Copper is more valuable than steel itself. Inside the cabin, every material is separated. Fabric, foam, and plastic are shredded and turned into new raw materials for industry. Once the car's shell is nearly bare, attention turns to its heaviest parts, the engine and gearbox. Some of them are refurbished and sold as rebuilt components. The rest are dismantled piece by piece. Aluminum housings, steel gears, copper wiring, everything is sorted by metal type. Even the catalytic converters are carefully processed. They contain precious elements like platinum, palladium, and rhodium, which are extracted through chemical refining. Every gram of metal matters. It holds the energy once mined from deep within the earth. Once all useful parts are removed, the remaining car body is sent to the mechanical cleaning zone. Here, massive hydraulic manipulators and steel jaws take over. These machines crush metal with tens of tons of force, ripping out leftover wires, plastic, and insulation. It looks destructive, but it's a crucial step in making recycling efficient. Robotic arms strip away impurities, leaving behind a clean steel and aluminum skeleton, ready for pressing and melting. This stage ensures the purity of the metal for the next phase. In just minutes, the car's frame is transformed into a clean, compact shell of raw material. Now comes the process that transforms bulk into precision. Gigantic hydraulic presses compress entire car bodies, with up to 200 tons of force. A 4-meter-long vehicle is flattened into a compact cube of steel in just seconds. This shape is perfect for storage and transport. Dense metal blocks resist rust and save space. There are several types of presses used in recycling plants. Balers create compact cubes for large industrial smelters. Flatteners crush bodies into flat plates for smaller recycling centers. Shear balers cut and compress simultaneously, preparing the metal for melting. Each method serves one purpose: to turn a heap of scrap into standardized raw material. This is how the cars of the past become the building blocks of the future. After compression, the metal blocks move to massive industrial shredders, the beating heart of any recycling facility. Inside, rotating steel drums lined with heavy teeth tear the blocks apart into smaller fragments. It takes only seconds, but the throughput is astonishing. Up to 150 tons of metal per hour. Steel fragments the size of a hand fall onto conveyors, where automatic sorting begins. Powerful magnets extract carbon steel, while eddy current separators pull out aluminum and copper. Plastics, rubber, and textiles are filtered out. The result: clean, separated streams of metal, ready for rebirth in the furnaces of steel mills. After sorting, the most breathtaking part of the process begins: metal melting. Steel fragments are fed into giant electric arc furnaces, where temperatures reach 1,600 Joule. Inside, electric arcs burn with the power of tens of megawatts, melting the metal within minutes. Each furnace can hold up to 200 tons of steel, transforming piles of old cars into a glowing lake of molten metal. To remove impurities, limestone and fluxes are added. They rise to the surface, forming a layer of slag that's later removed. This stage makes the steel purer, stronger, and more resistant. Engineers call it the moment of rebirth, because this is where old iron becomes new steel. After the primary melt, the liquid metal moves into secondary refining units. Here, its composition is precisely adjusted by adding alloying elements. Manganese for strength, nickel for corrosion resistance, chromium for shine, and molybdenum for heat endurance. Everything is fully automated. Sensors monitor temperature, oxygen levels, and chemical balance in real time. Computers fine-tune every parameter to achieve the exact steel grade, identical to the ones used by major car manufacturers. The result is a material that's indistinguishable from primary steel made from ore. This is the essence of modern metallurgy: recycled steel without compromise in quality. Once the composition is stabilized, the steel moves to the continuous casting machines. Through massive ladles, molten metal flows slowly into copper molds, where it begins to solidify. The temperature drops from 1,600 diours to around 900 diours, and the glowing liquid transforms into solid metal. Emerging from the molds are long steel shapes, slabs, blooms, and billets, stretching dozens of meters in length. They resemble rivers of fire, gliding across roller conveyors. After cooling with water jets, the slabs are cut into exact dimensions, each piece assigned a specific purpose. Within weeks, some of these steel blocks will become car frames, skyscraper beams, or railway tracks. The cooled slabs are reheated to around 1,100 dwellers and fed into rolling mills. These enormous machines use powerful rollers to gradually reduce the metal's thickness. With each pass, the steel becomes thinner, denser, and smoother. This is how sheet steel, beams, pipes, and rebar are made, the foundation of modern infrastructure. Some lines roll steel down to just a few millimeters thick, ready to be stamped into new car body panels. In a literal sense, old cars become part of new ones. The entire process is monitored automatically. Cameras and lasers measure surface precision, while robotic cutters trim the edges to perfection. Before the new steel leaves the plant, it undergoes a series of rigorous tests. In on-site laboratories, engineers check tensile strength, ductility, purity, and chemical composition. Samples from every batch are placed under hydraulic testing machines that measure how much force the metal can endure before deforming. Then come X-ray and ultrasonic inspections, revealing internal cracks or voids invisible to the human eye. If even a single parameter fails to meet the standard, the batch is sent back for remelting. These procedures ensure that every ton of steel can withstand pressure, stress, and time itself. When you see a brand new car gleaming under the sun, part of its body may have already lived several lives. It might once have been a truck, a bridge, or even an old train. Steel is immortal. It doesn't age, and it never disappears. It simply changes form. Every bolt, every beam, every car tells a story of rebirth, one that began in the heart of a recycling plant. And so, millions of old vehicles find new life, while humanity gains another chance to build a sustainable future.